Hello statistics student, this video is for chapter 8.2, confidence interval for mean with one sample, but in this case, sigma is not known. Now in 8.1, we have been doing this, saying that, to do the margin of error, we would need to calculate this, we have this formula where the margin of the error is calculated in if sigma is known, then the margin of error is C alpha over 2 sigma over square root n, because that's what the central limit theorem tells us how x bar spread out. You have to know sigma, right? How x bar spread out. Now, a lot of time actually sigma is not known. It's just in rare cases where sigma is known, like maybe standardized tests or data values that is known. People has done research on it for a long time, so you can have some kind of a known sigma all over the place. But a lot of times you'll be doing something new, you don't even know the mu. How would you know sigma? So we need another formula to calculate margin of error when sigma is not given. Sigma is not something that you calculate. It has to be given. Because if you can calculate it, that means you have all the population data, right? So the formula that we use is not depending on z anymore. It's depending on another distribution called a t distribution, sometimes known as the student t distribution. And the formula is t alpha over 2, just as if it is c, but it's now t alpha over 2. And instead of doing sigma over square root n, we just use the sample standard deviation s over square root n. So remember, do not use sigma over square root n and times t. Or do not use c alpha over 2 and do s. They can mix together. If you're using s over square root n as the tick mark for describing the distribution of x bar, you would have to pair it with a t distribution. So following this, I have a description of what is a t distribution. T distribution is a distribution that's that is the number of tick mark a particular x bar is. If you have an x bar, if you and then you minus mu, if you know mu, and you divide it by s over square root n. That means s over square root n is one tick mark. You would have a statistic called t. So this t distribution also has t, the mean is like a bell-shaped distribution, but it's not exactly a z. Z is bell-shaped with the mean equal to 0, but the tail is not as the same as z. So it has a higher tails. So if this is, if you draw the z distribution on it, z would have a closer, a smaller tail. So if we have a z level, we can just treat it as if it's a z distribution, draw the z level here, and you can still find the critical value t alpha over 2. Now to find this critical value, you would do the inverse t calculator. So you would not use this inverse normal, but you would do online stat book inverse t distribution. So for inverse t, you do not calculate, you do not give the area. You actually would tell us what is the confidence level, what is the degree of freedom, and then they will show the critical value for you. So this is primarily used for confidence interval. So we'll do an example of that later. So just remember, t distribution is used when sigma is not given. Okay. So it is still based on the fact that x bar is normally distributed. It's just that each tick mark is now not sigma over square root n, but each tick mark that you draw on to find area is s over square root n. So to find the confidence interval is still x bar minus e, x bar plus e. So this is no change. It's just that the E is calculated in another way because right now our tick mark is done by S over square root N. So let's do, and then the way you do it is you do stat this. So there is not another confidence interval, is not another formula. It's just actually the same thing. You still give confidence interval, you still give sample size, but just when they prompt you for population standard deviation, you would skip it because you don't know. So if you know it, you should use it, and behind the scenes, this will calculate by z alpha over 2. But if you don't know it, and behind the scenes, this will calculate the error, the margin of error by t alpha over 2. So in some software, you have to determine, like in graphing calculator, you have to determine whether you use t or z. But instead, you actually skip this determination. You just always use this analysis confidence interval mean from sample. So you don't need to distinguish yourself as to do T or Z. So that is the good thing. But you have to know that you do not give this, okay? Because this is not given. So so the other things is pretty much the same. The requirement to run this confidence interval is CLT has to apply, central limit has to apply. That means your X is normal or your sample size is greater than 30, and also your sample is a random sample. So let's do some example in 8.2. Okay, so example 1. Patients with insomnia are treated with sopicolone. I don't know what it is. It's like a prescription. After the treatment, the 16 subjects had a mean wake time of 98.9 minutes. So maybe they sleep not very well. They wake up for 1.5 hours during the night and a sample standard deviation of 42.3 minutes. So if you suffer from insomnia, you would wake up a lot. Assume that wake times are normally distributed. So construct a 98% confidence interval estimate of mean wake time for all patients. So this is a sample of 16 patients. They have this wake time and this standard deviation, and we want to find the mean wake time for all patients. Maybe you have to publish it to tell, oh, you are supposed to, the mean wake time for people treated with zopiclone is what? Okay. So because the wake times are normally distributed, so even if we have 16 subjects, it's fine because X is normal. But you can see that sigma is not known. So we would use T distribution. Okay. So to do that, we need to identify the same thing. We need to identify C level and X bar and S, but we would say sigma is not given, right? So in the worksheet, I would ask you what kind of the distribution would you use? You would have to say, oh, because sigma is not known, so we would use T because sigma is not given. Use T. Okay, use T distribution. And then if they ask for sigma, you would say not given. Right? So this points to the fact that you use T. And then you would use this and enter these in. 0.98 is a 98%, 16, 98.9, 42.3. Can I remember all those? 0.98. What is it? 16, 98 point, I don't remember. 98.9, 42.3. 98.9, 42.3. And then this you don't put, and then they would use T. So the error is 27.52, and the mean time that you wake up using that prescription is 71.38 and 126.42. How many decimal place? Yeah, I think 2 decimal is good enough. So you say 27, 126, 71.38. 379. Oh, I do 3 decimal here. So in a plus and minus format, you would use X bar, right? So X bar is, I had a typo here. It should be 98.9. So this would be X bar plus and minus E. So X bar should be 98.9. That's a typo here. Plus 27.52 minutes. So the mean time could be as low as 71 minutes, as high as 126 minutes. So can we conclude that the mean wait time is less than 100 minutes? Is the whole interval less than 100 minutes? Let's look at it. It's supposed to be 71.38 to 126.42, right? So do all of these less than 100? No. Some of them are less than 100, but I can't guarantee that mu is not here. Mu could be here, could be here. So you would have to make sure if you are to conclude, it has to be everyone is greater than 100. So in this case, it's no. The mean time can have value more than 100 because 100 is inside the interval. So the last thing is if the confidence level is decreased to 95%, what will happen to the margin of error? So earlier we do 98%, right? So if it's 95%, let's look at how X bar distribute. X bar will be, so this will be smaller, right? So 98% will be wider. So my T alpha over 2 would be more closer to 0. So if it's 98%, then T alpha over 2 will decrease. And so, but E is equal to T alpha over 2 times S over square root N. So T alpha over 2 decrease, that means E would decrease also because they are directly proportional. So the next thing we want to talk about is how to interpret confidence intervals of mean. How do we interpret it? If someone say, well, your mean is between 71 to 128, what would we say? So the wording that we say would be, we estimate with whatever confidence, 95, 98, that the true population mean for something, like maybe wait time, maybe score, is between this percent and this percent. Meaning you would say it that way, that you have to quote the confidence. You have to quote that it has to be between. The true one is between. Okay. The other way you can interpret this is if I collect confidence interval this way, 90% of the time, the true confidence intervals, the true mean would be in the interval. I would actually include it. Sometimes you don't because it is only 90% confidence. Okay. So the next thing is how do I make conclusion from a confidence interval? We have been doing this, but this summarized the whole thing. So whenever we have to make a conclusion of greater than or less than, we have to look at the whole interval. If the whole interval is greater than a number, we would say that mu could be because any of these is mu. If the whole interval is less than a number, then we can conclude it. But if we want to say, can mu be this number? We just have to say that okay, if this number is in the interval, mu can be that number. Okay, and also if two intervals overlap, we cannot say that they could be the same. So we cannot say that one is higher than the other. So remember, never make conclusion using the sample mean. Even if the sample mean is less than a number, you cannot say that the real mean is less than that number. So use the whole interval to make conclusion. So we'll do another video on what is it to do using data.